Okay, in this video, we're going to walk through a deployment of ScalarLM on a TensorWave node. So let's go to the TensorWave cloud, cloud.tensorwave.com. Okay, so we have one node that is running. Let's look at that. It's 8 MI300X GPUs, 1.5 terabytes of HBM3. And the GPUs are idle. You can also look at Grafana. You can look at temperatures, memory usage, utilization. Okay, let's log in. SSH into the node. I can run rockmsmi. I can see that there are 8 GPUs. Now, on this deployment, I'm assuming that we already have Kubernetes installed on this node or a collection of nodes. But if you don't already have Kubernetes installed, there will be a separate set of instructions that we'll cover in a following video that will explain how to set it up. So let's look at Kubernetes. You can say kube control. In this case, we've created a namespace that's called Llama 70 billion because we're going to show deployment of a Llama 70 billion model. And we can just say get pods. And there's nothing deployed currently. When you're setting up your Kubernetes environment, you're going to want things like the ROCm GPU operator, so we can allocate AMD GPUs. So if we look at all namespaces, we can see the GPU operator, AMD GPU operator that are already running there. Okay, so let's go into ScalarLM. This is checked out. If you don't already haven't checked it out, you can clone it from the repo. Clone it from a repo here. Okay, so for this deployment, let's go into the deployment directory, and we're going to use Helm. So in here, there's a number of reference Helm charts for different types of models. Here, we're going to deploy 70 billion parameter Llama. The most important file in the Helm chart is this values.yaml file. And this one is going to tell us which image we're going to be deploying. You can find a list of images on the ScalarLM website. Tag, we're going to deploy this as just a single service, and we're going to expose it on this server. We're going to allocate some memory for jobs. These are training jobs, which mean the model checkpoints. So we're going to allocate 100 gig for that. And we're going to allocate 200 gigs for the Hugging Face model cache. And that's going to be used to download the model, which is specified here. It says Llama 3.370 billion. You can pick any model from Hugging Face. For inference, we're going to set max inference length to 8K. This is typically there's a trade-off between how many requests you can submit concurrently versus how long the sequence length is. So this is just a common intermediate value. You can go up to the max value supported by the model. I think for Llama 3 it's around 128K. But if you did that, you'd be able to submit far fewer requests concurrently, and you may get lower utilization. This parameter is how much GPU memory to allocate for the inference workers. So we're going to allocate 95% of GPU memory for inference. And here, let's change this. Let's do, this node has 8 GPUs, so let's allocate 2 for training. We need at least 2 to be able to fit the Llama 3.3 70 billion parameter model. And then we'll use the remaining 6 GPUs to run 6 instances of VLLM as inference servers. So this config file is the most important config file when you're doing the deployment. We can look a little bit more detail at that, and we can see a little bit more about how this works. So this is our help chart. It installs a service that's called ScalarLM. And then we can see the services that happen here. So in this one, there's really 2 services. There's an API service, which is also the training worker service, and then there's VLLM services. So we can look at the VLLM deployment, and we can see that it gets replicated. So there's effectively one separate VLLM server for every inference GPU. And we can see it sets up local storage and networking, and it runs the same container. One important thing about ScalarLM is that even though there are different types of workers, there is a training worker and an inference worker, they all run the same image, and they are specialized in this config map, where the config map will say that this is a VLLM server instance. So start VLLM server, don't start the training server. It's effectively what's happening in this config file. The API service is similar. And note we're also requesting the GPU, the AMD GPUs from the Kubernetes GPU operator. Okay, so that's effectively it. I mean, these help charts are just a way of starting up a bunch of Kubernetes containers all at once. So let's do that. So let's deploy it. So we can do helm install namespace. We're going to install into this Llama 70 billion namespace. We're going to create a deployment that's called ScalarLM. And it just so happens that the local directory here is called ScalarLM. So we're going to run this command, and we'll see that the status is deployed. So we can watch kubectl name llama namespace llama 70 billion get pods. Okay, so see now all of the services have started running. There is a training service, which is also the API endpoint, and then there's 6 VLLM workers. So let's look at them. Let's just look at the logs from them to see what's happening inside. Logs for the API service. So we can see the API service started, and it's trying to connect to the workers, but the workers haven't come up yet. So we'll see that. Okay, and let's look at some of the workers. So let's take a look at this one, see what the workers are up to. Okay, the workers, when they start up, this is just how VLLM works. They load the model that's being served into GPU memory. This happens so that the GPU memory is hot, and when requests come in, they can just be served immediately. So as you can see here, this takes about 1 minute. Okay, and while we're doing that, I'm just going to switch over another tab, and I'm going to run this health check. So now that the server's up, I've actually exposed it on this endpoint. I had to create a network tunnel in order to enable this. I'm not going to cover that here, but the idea is I'm just submitting this curl request directly at this service that we just deployed. So we can run that. And we can see that the API is down, but the workers are down. And that is because, as you can see, they're still initializing here. Okay, so this loaded the model, and it's, you can see the maximum concurrency is 13x. And now it's creating the inference engine. This is going to take a little bit of time. As soon as it does, we will see the server come up. And when the server comes up, we will start to see health checks success, which we do here. So now health check is up. And now the deployment is complete and we can submit requests to the server. So that's really all that you need to do in order to deploy ScalarLM on a TensorWave Kubernetes node. While we're looking over here, let's look at our statistics. So we're going to go back into the server. We'll see that about 90% of the VRAM is used. And there was a training job that was already run that was restarted when we restarted the server. And so we can see that one of the jobs is training. And it's restarted from a checkpoint. And that one is using these two GPUs here, GPU1 and GPU2. And the remaining GPUs are idle because we're not running inference. Okay, and we'll also see that this is a this job that was scheduled here. This one, I could look at it. ScalarLM SQ. This was a multi-GPU job, and we saw that it is a single job and 2 GPUs are being used for training. Okay, so deploying ScalarLM on Kubernetes is pretty simple. This is showing deployment on a single node. Deployment on multi-node is identical. All you have to do is just specify more inference workers or more training workers, and Kubernetes will spin up the pods across your cluster using multiple nodes. The networking and collective operations inside of ScalarLM will automatically distribute models over your different GPUs, even if they span different nodes. Okay. In the next video, we'll probably cover how to bring up the Kubernetes cluster itself.